Number 5 from the 2011 test. Windmills generate electricity by transferring energy from wind to a turbine. A study was conducted to examine the relationship between wind velocity in miles per hour, mph, and electricity production in amperes for one particular windmill. Right there at that point, I remember teaching Algebra 1, teaching Algebra 2. Students have a really hard time distinguishing what's the x variable and what's the y variable, right? You with me? But you shouldn't have that problem in statistics on a problem like this, because whatever's by your slope, that is your x. Y'all see what I'm talking about? Put your devices away. You should all be with me. This is like focus time. The last time we get to work on anything together before the AP exam. Focus, okay? Y'all get that this is the y-intercept and this is the slope, okay? So whatever is by, this is our slope. Whatever is by the slope, that is your x variable. So there's no question about which one is y and which one is x. So looking at that, from the variables that they just gave us, the electricity production in amperes is our y hat, and then the wind velocity is our x. Are we okay with that? Because we're going to have to define it in a second. 0.137 is the y-intercept. Okay. For the windmill, measurements were taken on 25 randomly selected days. Halt. That's our sample size, right? 25 sample size. Okay. And the computer output for the regression analysis for predicting electricity production based on wind velocity is given below. The regression model assumptions were checked and determined to be reasonable over the interval of wind speeds represented in the data, which were from 10 miles per hour to 40 miles per hour. So we have all this information. Part A says use the computer output above to determine the equation of the least square regression line. Identify all variables used in the equation. I remember specifically that there was a problem like this on your chapter test, and most people got it wrong because they set up the equation and they did not define the variables. Y'all remember that? Y'all remember that? Okay. You have to read their whole thing. Don't assume you know what they're asking you to do. Read the whole thing. So we want to come up with the equation. We want to define all the variables that we use. In statistics, instead of y equals mx plus b, we do y hat equals mx plus b, right? And you'll notice the way I wrote it down, I did b plus mx. Is that okay? Yes. Okay. So I have y hat equals my constant of 0.137 plus 0.240 is my slope times x. So you always want to obviously attach the slope to x in your equation. So y hat is the predicted electricity production in amperes, and then x is the wind velocity in miles per hour. When you're talking about linear regression, you want to use the keyword predicted or estimated. It's not the exact electricity production, it's what we predict it's going to be. Does that make sense? So those are keywords the scoring guidelines like us to use. So for linear regression, try to throw in the word predicted and estimated as much as you can, because they actually will take you from an E to a P if they can't find that word, predicted or estimated, okay? How much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when the wind velocity is 15 miles per hour? Show how you arrived at your answer. So I actually just plugged in the x values of 25 and 15 to the equation, and then I subtracted them. And I'll tell you right now, that's not how the scoring guideline did it. But all they said is you had to come up with the right answer and show some work. It didn't specify that you had to do it their way. So their way was for you to notice that 25 minus 15 is 10, right? There's a difference of 10. And if we take 10 times the slope, isn't 10 times 0.24 still 2.4? And I will tell you that on this particular problem in the scoring guidelines, if you didn't use the unit, you got taken down from an E to a P on that part. So it's not enough just to say it's 2.4. You had to say 2.4 amperes. Are y'all okay with that? Let's say you did like the word credit, but you got the answer wrong, can you get partial credit? E's, P's, and I's, yep. But my point is that you don't want to get the right answer of 2.4 and not put amperes and get knocked to a P. That would make me cry. You know what I'm saying? Use your units. That's what I'm trying to say. Use your units. Okay? What proportion of the variation in electricity production is explained by its linear relationship with wind velocity? So what what variable goes with variation? Okay, standard deviation and variance have a good relationship. Standard deviation squared is your variance, right? And your variance is the square root, your variance is the standard deviation squared, and vice versa. The standard deviation is the square root of the variance. Yes? But that's not what that word is. That word is not variance. It's what? Variation. So no, it has nothing to do with standard deviation. Okay, Nick's saying R squared. What is he talking about? What's R? This is an important step. It's correlation. It's how strong of a linear fit you have. R is correlation. R squared is variation. Seriously? Okay. So when we describe a linear relationship, they're going to ask you for, I'm like cheating looking at the red Mickey head right now. You could do that. When they ask you to describe it, you want the form, the direction, and the strength. The form is whether it's linear or not. So linear or nonlinear. You could say linear or curved. The direction is whether it's positive or negative, and you just look at the slope to determine that. The strength is based on your R, okay, which is your correlation. And so if your R is 0, you are very, very like no relationship at all. Do y'all agree? 0 is a scatter plot. It's not linear at all. If you're +1 or you're -1, you're a perfect linear relationship. +1 or -1 is a perfect line. Okay, so anywhere in between, you're going to have different levels of strength. So we say if it's between, and like kind of think of it as the absolute value. You guys know that the R takes the same sign as the slope, right? Yeah, with me? So when I say from 0 to 0.5, I also mean from 0 to -0.5, okay? So 0 to 0.5 is weak. It's a weak relationship. 0.5 to 0.8 is a moderately strong relationship, moderately strong. And then above 0.8 up to 1, because 1's perfect, right? So 0.8 up to 1 is called just a strong linear relationship. Did you catch all that? And then the sign just tells you what the slope is, positive or negative. So back to variation. Variation is R squared. You never use the R squared adjusted. So on the computer printout, you never use the R squared adjusted. Please hear me. You just use the R squared. That is your variation. Okay, so it's 0.873. If you just wrote 0.873 for part C, you'd get it right. I changed it to percentage just because that's usually how we talk about it. We say 87.3% of the variation in Y can be explained by X. That's how you interpret it. And they asked it that way. So they didn't even ask you to interpret it. But isn't this saying 87.3% of the variation in in Y is explained by X? Do you see it? Because Y is the electricity produced and X is the wind velocity. Are we seeing it? Are we okay? Okay. So I'm going to move on, but that's R squared is variation. Part D, is there statistically convincing evidence that electricity production by the windmill is related to wind velocity? Explain. So if they ask you for statistically convincing evidence, do, state, plan, do, conclude. If they say hypothesis test, you do, state, plan, do, conclude. Okay, so when we do our state plan do conclude, you might notice that I kept forgetting something on my state plan do concludes, and it's in the state that I was forgetting it. Take a guess what I was forgetting. Alpha. Yeah, I got about 4 or 5 examples in and realized I haven't been defining my alpha. So you'll notice from then on, because you remember how I did my state plan do conclude. Don't I always do alpha after my HA normally? Sorry, it wouldn't fit because I kept forgetting to do it. So now my new thing is I just write it under the word state. As long as it's there, it just needs to be there. So always on the state plan do conclude. On state, I want you to always remember to do 4 things. Those 4 things are define your alpha, define your variable, HO, HA. So remember, it's 4 things. Define your alpha, define your variable, HO, HA. Don't forget to define your variable. That's what I see a lot of students forgetting to do. So in this situation, the variable we're using, and by the way, for hypotheses, HO, HA, you can only use population variables. You're going to use beta for slope. You're going to use mu for mean. You're going to use p for proportion, not p hat. Got with me? You have to use population variables and population values as well. Okay, so we have beta is the population slope. So HO is that beta is 0. HA is that beta is not 0. They're going to say when beta is not 0, then you have a linear function. Basically, because you don't have that constant horizontal line, you either have a positive slope or a negative slope. So you have some change going on. Does that kind of make sense? Kind of confusing. Okay, so our plan is to run a linear regression t-test. If we go to our calculator, don't do this because it doesn't work, but if we go to our calculator and we look at linear regression t-test, we will see from what they're asking for that we cannot do this on the calculator. Do you see that you can't do a computer printout on a linear regression t-test? What do we need? Lists of data, and we don't have that, right? So if they gave us an X list and a Y list, then yes, you could do the linear regression t-test on your calculator, but they don't. So for this one only, out of all the examples I picked for you, all 10 of them, this is the only one you really do have to do it by hand. You cannot just use the calculator for it. Okay, so to find the test statistic t, by the way, do we all know linear regression is always t? Critical values t for the confidence interval, linear regression and t go together, okay? So t is equal to the sample slope minus the hypothesized slope divided by the standard deviation of the sample slope, okay? So the hypothesized, the beta, we just get from the zero. That's like just kind of, I want to say it's a given, but you come up with it. But the other two values, we pull them from the computer printout. The sample slope is the one given, it's 2.4. The number next to it is the standard deviation of that slope, and it's always set up that way. So if you identify the slope, the number next to it is the sample slope. I'm sorry, the standard deviation of that sample slope. You with me? I said that backwards for a second. Okay. Ooh, I need to relax. Okay, so then I calculated that and got, yes ma'am, yes. It's sample slope minus hypothesized slope. So this is from, this sample thing, that is from the chart, and this is from what we're hypothesizing it to be. It's always going to be 0. And then this is from the chart as well. Okay, so then I did T-CDF. You know, if you had Z, you would do normal CDF, but we have T, so we do T-CDF. And why am I multiplying by 2? Because there's a 2 in front of there, and I don't know why. Because of the alternative hypothesis. Anytime the symbol is not equal to, we have to double it when we're working it out by hand. Please understand, if you're running the test on the calculator, it does it automatically, right? Do y'all get what I'm saying? If you're actually running the stat test, linear regression t-test, and you hit not equal to, it doubles it. So don't double it again. It's only when you're working it out by hand. Okay, so I'm going to do 2 times TCDF. This is my lower bound. I'm doing infinity as my upper bound. How did I get my DF? What is DF?
25 minus 2.
Okay, only for linear regression, it's sample size minus 2. Only for linear regression. For everything else, it's minus 1. But for linear regression, it's your sample size minus 2. And earlier, we said that the sample size was 25. So 25 minus 2 gives us a degree of freedom of 23. Does that make sense? Type all that in, and you do not get 7.88. You don't even get 7.89, okay? Can you have a p-value that's greater than 1? What does 1 mean as a p-value? 100%. Can you have more than 100% probability?
No.
You cannot win a game 788% of the time. It doesn't make sense, okay? You cannot have a p-value bigger than 1. So if you have something on your calculator that says 7.88, go look at the end of it, because it says E negative 12 on the end. Isn't that a lot of zeros? Yes, sir.
I thought if it said 7.88 times 7.12, that it was like 0.
It's 11 zeros in front of that 7.
How is it bigger than 1?
It's not.
That's my point. People will literally write down on their paper, P equals 7.88, fail to reject 812. You know what I'm saying? And it's not 7, it's 0. You get me? That's what I'm saying. Don't do that. It's not bigger than 1. It's actually so close to 0. Does that make sense to everybody? Okay. I just really want to drive that home because so many of you are happy to put, oh, the answer is 7.89, fail to reject. No, that's really small, so we reject HO. Okay. One thing that the publisher I have found does very different than the scoring guidelines. Y'all hear me on this. It's important. So when we did daily checks and when we did tests, I wasn't real picky with whether you said there's not convincing evidence or there is convincing evidence. What I have found in the scoring guidelines is they're very consistent. If it says reject HO, they say there is convincing evidence. If it's failed to reject HO, it's there is not convincing evidence. They consistently do it that way, so let's make the AP grader happy. If it's reject HO, there is convincing evidence, blah, blah, blah. If it's failed to reject HO, there is not convincing evidence, blah, blah, blah. Okay, and you'll see it. We'll do lots of examples on here. But let's try to be consistent in that. That way we make the AP grader happy. So we're rejecting, so we are saying that beta is not equal to 0. Okay, so we're saying this is a linear relationship, right? So I said there's convincing evidence that beta is not equal to 0. So electricity production by the windmill is linearly related to wind velocity. Always bring the context back. Okay. Now, I listed the conditions here for running a linear regression t-test. We didn't have to do that because somewhere up there it talked about that you assumed them to be true or something like that they were already verified. There was somewhere that it said they were already verified. Had it not said that, I would need to hit a bunch of conditions, okay? The conditions, you guys said y'all wanted to remember, the book did it as linear. We changed it to linear. Do you remember? L stands for linear. I is independent and is normal. E is equal standard deviations. We added in the A to remember 10%. Y'all said, let's do it as assumed 10% because that one was always there. And then R for random. So you would list them and then say how they're met. We didn't have to for this problem because it said it was already verified. Yes, sir.
What's equal standard deviation?
Equal standard deviation is that you don't have a bunch of outliers. Okay, so they're kind of like if you looked at your residual, they're scattered evenly above and below that residual line. You don't have a bunch of outliers that are really messing it up. So you would just kind of explain in general, in general terms. Don't get real specific on that one if you're explaining it. Just feel like, they're spread out well, that you don't have any extreme outliers. Anything pulling. Yes? You would say that your X's and Y's are independent, that each data point is independent from each. You don't have to prove anything, guys. Y'all need to kind of just give it in general terms because you don't want to write something down that would make it wrong either. So generalize, assume as much as you can. Okay, I threw confidence interval in there as an example just because I thought you needed to be reminded of it, but this problem didn't actually ask you to do it. So for a confidence interval, you always do your point estimate plus or minus your critical value times your standard deviation. So the point estimate for this problem is the slope. And then our critical value is going to be T star. And then our standard deviation is just going to be pulled from the computer output. It's the standard deviation of the slope. Okay, so I pulled the 0.24 from the computer printout, right? That was our slope. And the 0.019 as the standard deviation. Where did I get the 1.7139? Well, remember I said they weren't actually asking us to do a confidence interval, so I just made up an example. I'm like, what would we do if it was 90%? Okay. So if it was 90%, I would go second bars inverse T, right? It's inverse norm if you're looking for Z star. It's inverse T if you're looking for T star. So number 4, I want you to get in the habit of doing 1 minus your percentage divided by 2 because I don't want you to make a decimal mistake and get it wrong. So not worth it, right? Do y'all get what I'm doing? Because we are getting the area of the tail, okay? And then what's my degree of freedom? 23 because it's sample size minus 2. Paste it, enter, and you should see that you get the 1.7139, and then to calculate it, do the minus to get that low number, and then calculate it with the addition to get the high number. Are we okay with all of that? Questions, comments, concerns? Okay, on to the next one. A random sample of 200 students were selected from a large college in the United States. Each selected student was asked to give his or her opinion about the following statement. The most important quality of a person who aspires to be the president of the United States is a knowledge of foreign affairs. Each response was recorded in one of 5 categories. If you see categories, what should you already be thinking? Chi-squared. Okay, you should be thinking chi-squared if you see categories. Okay. The gender of each selected student was noted. The data are summarized in the table below. Is there sufficient evidence to indicate that the response is dependent? Dependent's a big word also for chi-squared, isn't it? Don't we have a chi-squared test for independence? And dependent, independent goes together? Okay, so provide statistical evidence to support your conclusion. State plan to conclude, okay? So for chi-squared, whether it's chi-squared or chi-squared goodness of fit, these are the only hypotheses that should be sentences instead of symbol equals a number. Y'all with me? These should be sentences for chi-squared. So for a matrix, that's just regular chi-squared, right? Do y'all agree with me that's a matrix of data? Because it's a table of data. For this one, your null is always no association between your variables. Alternative is there is an association between your variables. So the null is no association. The alternative is there is an association. When we do chi-squared goodness of fit, you ready to think through this one with me? Chi-squared goodness of fit, that's when you have your 2 lists of data, and list 1 is observed and list 2 is expected. You say for the null hypothesis that the observed is what is expected, and alternative is that the observed is not what is expected. So be careful with your no's. For association, no association goes in the null, but observed and expected, the not goes in the alternative. Y'all with me? Did I lose you? We're good? Okay. So there's no association between response and gender. Alternatively, there is an association between response and gender. So I kind of wanted to think through it on my own. That's what's in parentheses there of how does that apply to independence? And I was thinking to myself, okay, if there's no association, then that means that how I respond does not depend on my gender. So the response and the gender would be independent of each other if there's no association. The flip side of that, if there is an association, then how I respond is affected by my gender. And so then we have that dependence there. Does that make sense? Okay. That's just going to help me in my conclusion of how to answer their question. So my plan is I need to do a chi-square test for independence on every single state plan to conclude, regardless of what the data is, whether it's categories or means or proportions, I don't care. You're going to put random, right? No matter what, you're going to put random. You're going to put 10%. This is the only one I don't want you to put independent on. All the other ones put independent as well, okay? Would it make sense to say I'm doing a chi-square test for independence and they're independent? That doesn't make sense, does it? Y'all follow me? Like you're testing for independence and then saying it's independent, that doesn't work. So we're just gonna do random 10% and then how big of a sample do we have? And so the deal with chi-squared, whether you're doing goodness of fit or regular, is that your expected counts have to be at least 5. It's not the observed counts, it's the expected counts. Okay, y'all okay? Yes, sir.
If they fail that requirement, how do you improve it otherwise?
You can't. You won't be able to work out the problem. Yes, ma'am.
So you said you have to put independence on every single test?
You should, all the other ones, because I just kept seeing it in the scoring guideline, and it's not something we're in the habit of doing. We do random 10% large usually, but because in the scoring guidelines, they're putting 10% and independent together. A lot of times I'm seeing it in scoring guidelines over and over and over. So let's throw it in there just to be safe. Sometimes they don't grade for it though, but I'd hate for you to get docked because of that, you know?
Have they ever had it where the expected count is actually lower than 5?
No. Guys, and I talked about this in third period today. They're not going to give you a problem that you're going to stop at the condition and be like, I can't do this problem. And like, I'm done. Can't get any E's, P's, or I's. Like that. How do you earn your points then? They may ask you a question like, here's some data. Why can't you do it? And then you'd be like, oh, your expected counts aren't at least 5. But they're not going to give you data to do a state plan to conclude on that, oops, I'm stopping because I can't do the condition. Like, they're not going to do that. Yes, ma'am.
For independence, you just like assume independence?
A lot of times, like, you'll just say if it's men and women that they're, like, chosen independent from each other for the sample, something like that. Just real generalized, like, assume they're chosen independently. Yep. Okay, so let's put the data in. Y'all do this with me. How do we do this on the calculator? Second matrix, edit, enter. How big is it?
2 by 1 GB 4.
Type them in. Now what?
Stat SC.
You have to run the test to get it to create the matrix B, right? Everybody know that? You have to run the test first. Okay, so we want to go to stat test. He said C. I don't have them memorized, so I would just hit back. And he is correct. It is C. Because goodness of fit would be if we had lists. We want just the regular chi-square test. So we select that one. And then we just want to go down to calculate. And you'll notice that you get my answers under my do. Okay, write down the degree of freedom, even though we didn't calculate it ourselves. They usually do grade for the degree of freedom. So we want to write the chi-squared is 8.9226, the p-value is 0.0631, the degree of freedom is 4. Remember that to get those degrees of freedom, they took how many columns you have minus 1, how many rows you have minus 1, and then they multiplied it together. So 5 minus 1 became 4, 2 minus 1 became 1, and 1 times 4 is 4. Does that make sense? Okay, you might need to know that rule. Notice I'm not showing any work for this one. You might want to go a little bit further and say like your input on your calculator was A and what you actually put in, but I didn't even do all that. I just put the output. That is that. If you're an AP Bio student and you have a little bit of extra time at the end once you've tried all the FRQs, you might want to go back and show the work for chi-squared. But I wouldn't initially do that unless you had extra time because it's a lot to write out, isn't it? So I don't think you're going to get docked for not showing all that work, but if you're sitting there instead of doodling, go put some chi-square work in there if you really know what you're doing. But anyway, are y'all okay with what I've done so far? So my conclusion, I have a p-value of 0.0631 that's greater than 0.05. So we're going to say failed to reject HO. Remember, that's where I want you to start saying there is not convincing evidence. Notice I said there is not sufficient evidence. Convincing and sufficient, or you can use them either one. Okay, that's not the big deal. But there is not evidence to indicate that the response is dependent on gender because we are failing to reject. Does that one make sense? All good with that?
Would the conditions just be random 10% expected count?
At least 5. Thank you for pointing out my condition. I skipped it, didn't I? Expected counts all at least 5. Where did I get those numbers from? Second matrix, and go look at B. So second matrix, forgot we didn't look at this. Go down to B, select it, and you'll see all the values I wrote down. And it's not enough to just say expected counts are at least 5. You have to tell them what the expected counts are. Okay, so you are going to need to write that matrix down under your condition. Now am I good? Done with that problem? Okay. A humane society wanted to estimate with 95% confidence the proportion of households in its county that own at least one dog. Interpret the 95% confidence level in this context. This is the stuff I have confessed that I don't like, interpreting the confidence interval and interpreting the confidence level. You should all, I hope, be really good at interpreting the confidence interval by now. That's the conclusion sentence. Do y'all remember it? What is it? We are 95% confident that the interval from such and such number to such and such number captures the true population proportion of households that have at least one dog. But that's not what they want. They want the confidence level. This was the one I did like. You did it in your daily checks. It's in your brain somewhere. We just haven't done it in a long time. Okay. It's in your, okay. It's in your brain. Like I said, it's in her brain right here. But anyway, so confidence level is going to be, you need to remember to say you're doing repeated samples of the same size. And in the long run, this is going to be true. Okay. Repeated samples of the same size in the long run. Do y'all remember doing this sentence? We didn't like it, but we did it. Okay, so in repeated samples of the same size from the population, in the long run, 95% of those intervals would capture the actual population proportion of households in the county that own at least one dog. Okay, so it's the repeated samples of the same size thing. And then in the long run, that many percentage of the intervals would actually capture what we want to capture. Are y'all okay with that explanation? Okay, cool. The Humane Society selected a random sample of households in its county and used the sample to estimate the proportion of all households that own at least one dog. The conditions for calculating a 95% confidence interval for the proportion of households in this county that own at least one dog were checked and verified, and the resulting confidence interval was 0.417 plus or minus 0.119. How did I get those numbers that are next to that? You subtracted first to get 0.298, and then you added to get the 0.536. Everybody okay with that? Okay. Looking at this setup, what is 0.417? That's the test statistic. That's the p-hat. That's the point estimate. Are y'all with me there? That is the point estimate. What is 0.119? Margin of error. The margin of error is made up by the critical value times the standard deviation, which is also called the standard error, right? So 0.119 is they took the critical value times the standard error. We don't see that work. All we know is the margin of error is 0.119. Are we okay with all that? Because we're going to use it in a little bit. Whew, okay. A National Pet Products Association claimed that 39% of all American households own at least one dog. Does the Humane Society interval estimate provide evidence that the proportion of dog owners in its county is different from the claimed national proportion? Explain. Is 39% in our interval? Yes. So no, it's not different from 39%. Isn't that weird? The way they asked it to me is weird. Instead of just saying like, is 39%, possible? And you're like, yes, it is because it's in the interval. They asked, is it different from that? No, it's not different from that because 39% is in the interval. Does that make sense? Are we good? Part C. How many households were selected from the Humane Society sample? Show how you obtained your answer. So this is the part that students are struggling on the algebra. You're not liking it for some reason. But I'm doing the margin of error is equal to z star times p hat times 1 minus p hat over n, and I'm solving for n. I'm getting margin of error from right here. Agree? I'm getting p hat from right here. Okay, so I'm going 0.119 equals, where did I get 1.96 from? It's a 95% confidence interval. We've memorized that that's z star is 1.96. If you didn't memorize, what would you do in your calculator? Is that okay? You can do it like that. Please get in the habit of doing it like that. Just do it on there. Put the 1.1 minus your percentage in parentheses and then divide by 2. It's going to work for you every time. Do y'all see the 1.96? Okay, so let's try to do it this cheating purple Mickey head way, okay? We're on proportions, right? We're just going to plug in and not have to do any algebra.
So when they use p hats, or is it because they didn't give you?
Confidence intervals are always p hat because aren't you estimating what p is? So you don't have p. You're estimating what it is. So always confidence interval is going to be p hat. Okay, so I'm going to try that formula over there so that you don't have to do any algebra. So I'm going to go alpha y equals to get the fraction button. On the top, we're doing 0.417 times 1 minus 0.417. Are you with me so far? Okay, cool. Divided by parenthesis alpha y equals to get a fraction. We need to put the margin of error on the top and the z star on the bottom. What's the margin of error? 0.119. What's the z star? 1.96. We need to come off the fraction, close the parenthesis, square it, and we have our answer. Okay, but you'd have to either memorize or figure out a way to have those formulas on the test because they won't be on the formula sheet.
Figure out a way.
Wink, wink. Moving on, right? Done? Moving on? Yes? Yes, still with me? Yes, sir.
For what type of test would you use a population? Do you ever use population proportion for any?
Not for confidence interval, but for hypothesis testing, we're gonna do like P equals the population proportion. We will have an example, you'll see. But we'll definitely use those values within our hypotheses because we never use sample values in our hypotheses. Here we go.
You know where cheaters like so
Program, new. You do la 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 la, press enter, and then you go second alpha, and now you're locked in and you can type whatever you want. That's a space. You see what I'm saying? Moving on. Ready, ready, ready? A bottle filling machine is set to dispense. Come on, guys. Here we go. 12.1 fluid ounces into juice bottles. Right away, your wheel should be spinning. Is that an average or proportion or category? What is that? That's an average. It's not saying like what proportion of juice bottles are full. It's saying on average, we put 12.1 ounces in there. Does that make sense? So I'm dealing with mean, so I'm dealing with T. You should be thinking that as you're reading the scenarios. To ensure that the machine is filling accurately, every hour a worker randomly selects 4 bottles, ding, 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 that's our sample size, 4 bottles, filled by the machine during the past hour and measures the contents. Right now you should be getting a headache because we can't run a t-test because we don't have the sample size we need. What does our sample size need to be? 30. Means is 30, right? Means is 30. Okay. So if there's a convincing evidence that the mean amount of juice dispensed is different from 12.1 ounces, or if there's convincing evidence that the standard deviation is greater than 0.05 ounce, the machine is shut down for recalibration. Here's the best sentence of the whole part. Ready? It can be assumed that the amount of juice that is dispensed into bottles is normally distributed. So it's okay that our sample size is only 4 because we get to assume it's normally distributed. That's nice, right? Okay. So during 1 hour, the mean number of fluid ounces of 4 randomly selected bottles was 12.05 and standard deviation was 0.085 ounce. So let's really make it clear which is which. Okay, mu is 12.1. Agree? X bar is 12.05. Y'all get me? Sigma is 0.05. S is 0.085. Am I good now? Okay, fantastic. Perform a significance test to determine whether the mean amount of juice dispensed is different from 12.1 fluid ounces. Assume the conditions, oh, that's beautiful. Assume the conditions for inference are met. Anytime it says that, under the plan, you name the test and say, oh, they're already met, and you move on with your life, and you don't have to list them all. That's the most beautiful thing ever. Okay, but back to the state, you still have to do all the state, okay? So state is 4 parts. Define your alpha, which I keep forgetting to do, so alpha is 0.05. Define your variable, HO, HA, okay? So alpha is 0.05, mu is the true mean. I don't know why I didn't write true, because I usually do. It's the true mean amount of juice dispensed, okay? HO is that mu should be 12.1, okay? Alternatively, mu is not equal to 12.1, because they're testing to see if it's different from. It doesn't say greater than, it doesn't say less than, it's just different. Are y'all okay with that so far?
Yes.
Plan is that it's going to be a t-test because it's means. Yes, sir.
I thought you were supposed to use C-test when you're given the population standard deviation.
They do t-test. I'm with you, though. We don't ever do that. Don't touch that. The testing. You didn't have to do math, just sex test. Can I keep going, though, please? With me? Back with me here? Okay, so on the do, you're really probably not going to do what I did. Would you agree? Aren't you just going to use your calculator to do a t-test? Okay, so you're going to go stat test. And which one is it? Number 2, do we have data or do we have stats? You're not going to do data because we don't have a list of data. We have stats. So go over to stats. What is mu naught? Guys, it's the hypothesized population mean, 12.1, okay? What's X bar? What's SX? What's N? What's our symbol? Have you ever looked at draw?
No.
What's wrong with you?
Sorry. Yes.
It's cute. It's cute. It just draws a curve for you. It shows you where the p-value is. It's shaded in blue. And at the bottom, it gives you your test statistic and p-value. So it's kind of cute. You don't have to do it that way. But if you're like at the end and you're doodling, go back and draw them some pictures. You can get credit for pictures. Okay, so if you want to, you can draw a little sketch for them. Don't doodle in the AP test, please.
You just said like if you're doodling.
That's what, instead of doodling, I want you to draw normal curves instead. Okay, do y'all see that me working it out by hand gets the same test statistic and that me working out by hand gets the same p-value? Ish, it's close. I know it's hard to read up here, so let me rerun it so you can see it a little bit better without draw, but I just wanted you to see the draw because sometimes it helps you visualize it and then you feel more confident in your answer if you can kind of visualize how it's looking. But do you see that that's pretty close, like 0.32? I mean, but I worked it out by hand, and so I'm off a little bit, but it's close enough. Would you not agree? Okay. So did I double it? I doubled it when I worked it out by hand, but not when I ran the test. It does it for you. Don't double it again. Okay, so 0.32 is bigger than 0.05, so we fail to reject. So there's not convincing evidence, blah, 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 context of the problem. Are y'all okay with that? Yes, ma'am.
So you don't use sigma under X bar minus mu. If they do use sigma, you still do this.
Usually you're not going to have sigma. Usually. That's a weird thing that they gave us both. Are we on B? I picked B or kept B just because it reminded me of the guppies. You remember the guppies in the daily check or practice worksheet or whatever? It's just like that. So let's just try to figure it out. Here we go. To determine whether the sample of 4 bottles provides convincing evidence that the standard deviation of the amount of juice dispensed is greater than 0.05 ounce, a simulation study was performed. In the simulation study, 300 samples, each of size 4, were randomly generated from a normal population with a mean of 12.1 and a standard deviation of 0.05. The sample standard deviation was computed for each of the 300 samples. The dot plot below displays the values of the sample standard deviations. So what we're going to say is if that really is the distribution of standard deviations of 0.05, then how often would we get that sample standard deviation of 0.085? And so what I did was I counted literally how many dots were at 0.085 or higher. And I sat there and I counted them, and there really are 12 of them. There are 300 total dots there. I just believed them on that, okay? But I did count those 12 right there. I was willing to do that for you. So 12 out of 300, went on my calculator and found out that that's 4%. Y'all with me so far? Okay, so a standard deviation that exceeds our sample standard deviation of 0.085 happened 12 out of 300 times, which is 4% of the time. If the actual population standard deviation really is 0.05, then the probability of getting a standard deviation that's that sample standard deviation, that 0.085 or larger, is 4% of the time that's going to happen just by chance. So 4% is less than our alpha level of 5%, so aren't we rejecting? So then we do have evidence for the alternative. And I kind of just, you didn't have to write this out, but I wanted to think in my brain what my hypotheses would be. My null would be that my standard deviation is the 0.05, and my alternative would be that it's greater than 0.05. So since I'm rejecting, there is evidence that it's actually greater than 0.05. So they need to recalibrate that machine based on this sample data. Simulated data, excuse me. Are you ready? Ready for the next? Are you getting anything out of this? Am I working hard and you're chilling? Because I feel really, really tired today. I worked really hard for you people today. Here we go. Keep going. You're having a blast? Are you remembering stuff? That's the goal. You wrote down like one thing. That's good. Whew. She's got a lot of stuff. Okay, here we go. A large pet store buys the identical species of adult tropical fish from two different suppliers, Buy Right and Fish Friends. Several of the managers of the pet store suspect that the length of the fish from Fish Friends are greater than the lengths of the Buy Right. Random samples of 8 adult fish of this species from Buy Right Pets and 10 adult fish of the same species from Fish Friends were selected, and the lengths of the fish in inches were recorded as shown in the table below. Blah. Do the data provide convincing evidence that the mean length of the adult fish of the species from Fish Friends is greater than the mean length of adult fish of the same species from Buy Right Pets? So on our state, we need 4 things. Define alpha. Alpha is 0.05. Define your variables, HO, HA. Okay? So alpha is 0.05. Mu of B is going to be the true mean length of the fish that are from I keep calling it Best Buy Right Pets. And then mu F is going to be the mean length of the fish that are from Fish Friends. Y'all get my definitions there? And so the null hypothesis is that the fish are going to have the same, regardless of which store you buy them at, the mean is the same. So mu of B equals mu of F. But they hypothesize that the Fish Friends has the bigger fish. And so we want to go mu of B less than mu of F. Does that make sense? Okay. What type of test are we running? We're running a 2-sample t-test. These are 2 completely separate samples. Do you agree? Yes. But it's a t-test because it's their average length. It's means. Okay? Random, independent, and 10%. All the fish are taken out of the take independently. We assume that 8 is less than 10% of all the fish at Best Buy, which is now Buy Right, whatever. And then 10 is less than 10% of all the fish at Fish Friends. Y'all get the 10% thing? Because you would need to write it out. And then, hey, what happened with my large sample? And random was stated, by the way. Doesn't meet it. For means, what do you need your samples to be? At least 30. At least 30. You don't get to stop and give up. You don't. You graph it. You show that there's no outliers and strong skewness, and you move on with life. Okay? So what I did, don't take an L. We want E's, not L's, right? There's no L option. No L's. Okay, so what I did, you ready? I need this data anyway to run the test, so I went in and put it in lists, and then I let my calculator create the box plot for me. That's what I did, so I'm going to do this real quick. So, hey guys, if you have stuff like in your calculator you don't want to use and you're in the middle of the test and you have stuff in the list, how do you fix it? You don't want a 2 + 7, 1, 2. If you have something in your calculator you don't want to lose, you don't want a 2 + 7, 1, 2. Are y'all hearing me? Don't clear your RAM. It wipes everything. No. Okay, watch. Are y'all with me? You go up to L1, you hit clear, you hit enter, and it clears out that list. Don't hit delete because it will literally delete the list. Clear enter, folks. Don't listen to him. There's a way to clear list. You go, why are you making me do this? You go second stat, and it's clear list. Wait, just kidding. Stat, clear list, number 4. And you get to pick which list you want to clear. So you can be like L3 or whatever. But why are you making me do that? I need to put this data in.
Oh, if you go second plus 4, it's clear all this.
Oh, that's cool. I learned something today. Can I go home now? Isn't that the rule? If you learn something each day, you get to go home. But you need to stay here if you don't learn anything. That would be a good rule, right?
Second plus, and then clear entries is bring you out of the I'm scared that I'm gonna delete the program I started to
Come up with.
Oh yeah, hey Nate. Mayor. Who's printing the place?
Can we get back to AP Stats? Because our test is in 2 weeks. Guess where 2 days. Can you believe that in 2 days you'll be sitting in the gym?
No.
Can we do this so please?
I cried 3 times going into my AP normal science test, so I can't wait for that.
Guys, focus. Look at our time. It's ticking away, and I want to do as much as I can to help you on Thursday's test. Here we go. Okay, so I want to get these graphs. Do you understand what I just did here? So I'm going to go second y equals, now that I have it there. I'm going to press enter. I'm going to turn it on. I'm going to pick the box plot that shows outliers because I don't want outliers. I want to see them if they're there. Of L1, I'm going to hit zoom 9. You're never going to hit graph on the SAS test. You're going to hit zoom 9. Okay. I remember giving this to you on the secure FRQ, and many people missed it because you didn't put the values on your graph. There's no values on my graph. What do? You hit trace, and then you toggle to the right. 2.7, 3.15. Do you see where I got the numbers from? 3.4, 3.65, 4.1. Do you see it?
You can also just go back to stat and do stat.
That's too much work. You learned something today. Okay, turn it on. Pick the one that has the outliers. Make sure it's on L2, right? You don't want the same graph again. You want the other graph. L2, zoom 9, and then trace. And notice I'm on the blue one. You're stuck up there. No, hit down and you jump to the red one. And then it'll tell you the values at the bottom. To me, that's quicker than one variable stats and scrolling and everything. Okay, moving on.
But if you forget they have to trace or something.
Okay, back to this. Ready? Run the test. We're going to go stat, test. What is this? It's a 2-sample t-test. Which one is that?
4.
Okay, we have stats or data. We have the data list, right? L1, L2. What's our alternative symbol? It's not equal to. No. It's less than, right?
Stats.
We'll talk about that in a second. Let me carry on. Hold on. You're right, though. Are y'all cool with what I have typed right now? Okay, so then I go down to calculate or draw, whichever one you like, and you'll see that we should get a t of negative 0.2587 like I did by hand. We'll get a p-value of 0.3996. Check out that DF. It's not 7. When I did it by hand, I just estimated that it's the smallest sample size minus 1. Okay, but do you remember a long time ago when we did like chapter 8 or 9 or whenever we did this that it was a big ugly formula? You don't have to show that work, guys. Just get the DF off the calculator. Okay? Don't show all that big ugly work. Do y'all get me? Okay. And then make your conclusion. We know that's greater than 0.05. We say fail to reject HO, so this is not convincing evidence. So Drew was saying, can I do it with stats? This is a different kind of problem because they also give you the stats, don't they?
Yeah.
So it's still 2-sample t-test, but I want you to notice if you hadn't done the listing, but you had to do the listing to get the graph. You see what I'm saying? But anyway, they do give you enough data to do the stats. So they give you the 3.4. They give you the 0.434. They give you sample size of 8. They give you 3.46, standard deviation of 0.550, a sample size of 10, we're less than, and we calculate, and we should get the exact same answer as Drew. So you can do it either way. Okay, this one's different, even though it almost looks the same. Y'all want me to stop?
No.
Okay, stay with me then, because it's hard to get distracted. Okay, investigators at the U.S. Department of Agriculture wish to compare methods of determining the level of E. coli bacteria contamination in beef. Two different methods, A and B, of determining the level of contamination were used on each of 10 randomly selected specimens of a certain type of beef. The data obtained in millimicrobes per liter of ground beef for each of the methods are shown in the table below. Notice from our table, it doesn't specify this, but aren't all 10 specimens going through both methods? So what type of test is that? Match pair. Do y'all see it? Because one is going through A and one is going through B, so it is its own match. Is there a significant difference in the mean amount of E. coli bacteria detected by the two methods for this type of beef? Provide a statistical justification to support your answer. We're only going to test the mean difference, not them individually this time. Okay? So what I'm going to do in this situation, first of all, I'm going to go to my desk and I'm going to type that data into list 1 and list 2. I'm going to my desk because it's a lot of data and it's faster at my desk. So remember that to clear this out, you want to go up to L2, hit clear, and hit enter. Or we can do Barrett's trick. He said to do second plus 4 for clear all lists. I guess you have to press enter. It doesn't want to work. Okay. And he's hired. Okay. Thank you, Barrett.
You have to say method and kind of method because if it's just different.
I don't know.
Okay, guys, I need y'all to pay attention. So we need the difference of A minus B. Do you really want to sit here and calculate 22.7 minus 23.0 and then minus no. You go up to L3, you go second 1 minus second 2, enter, and it does it for you. Okay, you with me? Do we have a big enough sample size?
No.
We're dealing with mean difference. It's still got to be 30. We only have 10. Doesn't work. They don't like you. So to graph it right there, what I did is I did a box plot of L3. Go with me? So I did second y equals, turn it on, make sure it's on the one that has the outliers, go up and select L3. I'm also going to go turn off the second one because I don't want it messing up. It's like old data. I don't want to deal with it. So it's off. And then I'm going to zoom 9, and that's where I got that from. And yes, I did hit trace to get those values. Are we good? Are we good? FRQ can be done or pen or pencil. Is that what you're asking? Multiple choice has to be pencil on the bubble sheet. FRQ can be pen or pencil for stats.
Is it pencil for math? Can it be pencil for science?
Yeah. On the yourself.
It can be pencil or pen. I have both from past students.
I've never taken like a math or a science one, so like I always just assume.
But you have to have a pencil for the bubble sheet.
Yeah.
Okay. Let's run the test really quick on the calculator. I'm trying to speed through these so I can get to some more examples. So I'm skipping stuff, but you can go back and read this if you want to. But I would do, to actually run the test, I would do stat test. What kind of test is it? Match pair t-test is not there. That's just a t-test. Y'all get me? Okay, so it's number 2, but it's of L3, because isn't that where I put the mean differences at? Okay, so I want to be on data, and I want to tell it to do it of L3. I don't want to forget to do that because I've already done it twice today where I left it on L1. Hold on. What's my hypothesized mean, though? Zero. Because if the methods are exactly the same, then wouldn't their difference be zero?
Yes.
Question?
Did you have done the L1 minus L2 where it says list right there?
I don't think so.
Okay.
I haven't tried that. Yes, ma'am.
For like the plan, can you just write t-test or is that too much?
You could put t-test if you're not confident, but you might get a little extra for the match pair. When they're trying to decide if you're a 2.5 or, you know what I'm saying, goes to a 3 or a 2, those kind of details might help you get put up a notch. But if you just put t-test, you should be fine. Am I good there? Do I need to change anything? I do. I'm waiting for you to tell me what not equal to. There you go. Are we good now?
Yes.
Okay, calculate, and you'll see that I should get a t of 1.4563-ish, a p-value of 0.1793-ish, and then I would fail to reject. There's not convincing evidence, blah, blah, blah. We're good? Okay, some boxes of a cereal brand of breakfast cereal include a voucher for a free video rental inside the box. The company that makes the cereal claims that a voucher can be found in 20% of the boxes. Percent is proportion, right?
Yes.
They are going to go on and use the word proportion in a minute, but I just want to point that out to you. A percentage is a proportion. However, based on their experiences eating the cereal at home, a group of students believes that the proportion of boxes with vouchers is actually less than 0.2. This group of students purchased 65 boxes of cereal to investigate the company's claim. The students found a total of 11 vouchers for free video rentals in the 65 boxes. So we have a P of 0.2 and a P hat of 11 out of 65. Do y'all get me? Okay. So for the state, we have 4 parts. We always do alpha's 0.05, define our variable, and HOHA. So our P in this situation is going to be the true proportion of all boxes that have the video rental or whatever the voucher. So the null hypothesis is that it really is 20%. So HO is P equals 0.2. And then HA, the kids think it's less than 0.2. So does my HO and HA make sense? Never use sample symbols, so you should never have P hats in there. Okay. Our plan is to do a 1 sample z-test for a proportion. I think if you call it a 1 proportion z-test, you're fine. That's what it's called on the calculator. 1 sample z-test for a proportion is just a little bit more specific. Random, 10% independent. Are y'all okay with all that? For proportions, we do large counts. Large counts is NP greater than or equal to 10 and N1 minus P greater than or equal to 10. And it's the P that's hypothesized, not P hat. Okay, so we need to do 65 times 0.2 and 65 times 0.8, right? And luckily this time they are both at least 10, so we don't have to graph it. Moving on. So I would do stat test, 1 proportion z-test, which is number 5. Would I have, I don't have an option between stats and data, do I? Okay, so what's my P, my P naught? 0.2. What's my X? 11. It's how many vouchers they actually found. What's my N? Does that make sense? Y'all okay with that? Okay. What's my alternative symbol? And calculate, and you should get negative 0.6202 for the Z and 0.2676 for the P. Everybody go with that? And if you divided 11 by 65, you really would get the 0.1692, blah, blah, blah. It's just not that important. Yes, ma'am.
If it weren't and large counts work, how would you graph the proportion?
I've actually seen examples where they're like, large count doesn't work, but we're going to carry on. It did that to us in the daily check. I've never seen it in the FRQ. So I don't think the College Board's going to do that to you. Yes, sir.
Could you go over like all of those distances to variable things and the ones for proportion? I mean, for the population.
Okay, so he wants to know what's population variables. Y'all gotta help me. And what's sample variables, right? Okay, so what is it for mean for population? What is it for sample? Okay, what is it for proportion? It's regular P for population. It's P hat for sample. What is it? What is it for standard deviation? Sigma for population and S or SX for sample. Were there others? I think that's pretty much it, right?
So population is just like the simple ones. Sample is like
sample size, it can be N for population and lowercase n for sample. However, capital N sometimes is normal. Capital N can sometimes be the notation for saying it's a normal distribution.
How about slow?
How about what? Oh, slope. Didn't think of it. For population, it's beta. I'm out of room. And then for sample, it's just regular B.
When do you have to write?
And actually, I think on the formula sheet, they call it B1. And they'll call it B naught. Oh, I'm thinking of B naught for the y-intercept, not for population. Question?
It's a lot easier, thank you.
De nada. Moving on. Ready?
Yes.
For many years, the medically accepted, we saw like pre-more. Okay, for many years, the medically accepted practice of giving aid to a person experiencing a heart attack was to have the person who placed the emergency call administer CC, chest compression, and standard mouth-to-mouth resuscitation, MMR. CC stands for chest compression. MMR stands for mouth-to-mouth resuscitation. Do you know what they're talking about? They're like, shh, breathe, shh. Okay, so then they found out that chest compressions alone are actually more successful. Have you heard this before? And not doing the mouth-to-mouth.
It's only for water, right? It's like the only thing you should do mouth-to-mouth. If there's like water floating along.
However, some researchers believe that CC alone would be a more effective approach. Shh. In the 1990s, a study was conducted in Seattle. Yes, it was Grey's Anatomy. I'm just kidding. In which 518 cases were randomly assigned to treatments, 278 to CC plus MMR, and then 240 for CC. A total of 64 patients survived the heart attack. That sounds terrible. 29 in the group, like you start bawling during the AP test.
This be a question where you're like, I can't do this because of this.
Because I'm bawling, you just made me sad.
It's because it's not experiment. But it just.
We got to keep going. 29 in the group receiving CC plus standard MR, and then 35 in the group receiving CC alone. A test of significance was conducted of the following hypotheses. Do not write your hypotheses the way they're demonstrating right now. I don't like it. Don't do it. But here we go. HO is that the survival rates for the two treatments are equal. We would do like P1 equals P2 and define P1 to be the proportion that had both and P2 to be the only CC. But they didn't do that. Alternatively, the treatment that uses CC alone produces a higher survival rate. Okay? The test resulted in a p-value of 0.0761. So interpret the p-value. Remember that the p-value is the probability of, y'all remember this? It's on there. The p-value of 0.0761, which is a 7.61% chance, that's the probability of observing a difference between the two sample proportions as large or larger than, because it's greater, right? We want CC to be greater than the one observed, if the survival rates for the two treatments are really the same. So your p-value is the probability that's going to happen. Well, the sample could happen if the null hypothesis is true. Okay, part B, based on this p-value and study design, what conclusion should be drawn in the context of the study? Use a significance level of 0.05. So they gave us a p-value of 0.0761. It's greater than 0.05, right? So we failed to reject HO, so there is not convincing evidence, blah, blah, blah. Are you okay with that? Yes? So what kind of error could we make for part C? Based on it, then what kind of error did you make, type 1 or type 2? Type 2. So you have to memorize or put it in your brain. That type 1 is when you reject. Type 2 is when you fail to reject. That's locked in. They go together. They're not interchangeable. Okay? So they're both errors, though. So type 1 is when you reject the null hypothesis in error. So that means that your HO was true. Type 2 is when you failed to reject an error. And so that means that your HO was false. Power is correctly rejecting HO. So that means that your HO really was false and you rejected it, so it was a good thing. Okay? How do you increase your power? It's not asking here, but I'm asking. Increase sample size. Increase significance level, the alpha. How do you increase power? You increase sample size, increase significance level.
So what is alpha in relation to beta?
0.05. Beta, they're different curves.
They're completely separate.
Well, they have a little overlap. Google it. I'm going to keep going. Do two more. I think two more. Okay. Can I keep going? Please, please, please. Can I keep going? We still have time. A French study was conducted in the 1990s to compare the effectiveness of using an instrument called a cardio pump with the effectiveness of using traditional cardiopulmonary resuscitation, let's just call it CPR, in saving lives of heart attack victims. Wouldn't you just cry at this point during the test? Like, we've seen it twice now. Blah, blah, blah. Heart attack patients in participating cities were treated with either a cardio pump or CPR, depending on whether the individual's heart attack occurred on an even number or an odd number day of the month. Before the start of the study, a coin was tossed. Isn't that random?
I think so.
Okay, coin toss, even, odd, that's your randomness, so you need to talk about it in your random condition. The other treatment was given on the odd number days. In total, 754 patients were treated with a cardio pump, 37 survived. 746 patients were treated with CPR, and 15 survived. Can y'all listen, please, please, please? I'm going to teach you something new that I promised to teach you about 3 months ago. Yeah, and I never taught it to you. In part B. The conditions for inference are satisfied in this study. State the conditions and indicate how they're satisfied. We're dealing with the proportion of people that lived, proportions, so we need random 10% independent large counts, okay? But you have to do the NP greater than or equal to 10 for the cardio pump people and for the CPR people. Then you have to do the N times 1 minus P greater than or equal to 10 for both as well. So you really have 4 different ones. Do you see them? Do you see them? Do you see them? Okay, so let me teach you something I never taught you before. Here we go. I promised you a long time ago I would teach you this, and I never did. Okay, when we had 2 separate proportions like that and we were working out the z-score by hand, we just kept them separate. And I remember Sydney specifically saying, but what's this combined thing? And I'm like, don't worry about it. And I don't want you to worry about it. I don't want you to leave here mad at me because 3 months ago I was supposed to teach you something I didn't teach you, because your calculator handles it for you. I'm going to show you that you don't have to learn what I'm showing you right now, okay? But if there were a question that came up about it, I want you to be aware of it, okay? They have what's called a P-hat-C. I'm going to say the C stands for combined. It's if you combine the proportions together, okay? So the P-hat-1 group, can y'all stay with me here, is 37 out of 754. Our P-hat-2 group is 15 out of 746. If we combine them together, then you would add 37 plus 15 on the top, and you would add 754 and 746 on the bottom, and you would get your new combined proportion. That is how they solve these problems by hand. Our calculator does all that for us, okay? But do you get my work over here? Combining the x's on top, combining the n's on top. I use the calculator to simplify it, and it's 13 over 375, okay?
Where does that go?
It goes here where you see these C's, okay? But can I just show you that the calculator takes care of it and you don't have to think about any of that? Okay, so what type of test is this? What's it going to be called here? It's not sample, it's to proportion z-test, right? Would y'all agree? They're proportions. Is that number 6?
Yes.
Okay. And we have these values. So our first group, they got the cardio pump, aren't they 37 out of 754? Okay, and then the people that got the CPR, 15 out of 746. And then we think that cardio pump is bigger than CPR, so we're going to go greater than. Guys, I really did work that out by hand and got the exact same answers your calculator gives you, okay? So you don't have to do the combined thing. You really don't. You'll get the same answers. Do you trust me?
Yeah.
That's why it was really never a big deal to me, okay? Last one. Hey, guys, we have 4 minutes for a goodness of fit. We end on a fun one, okay? You're spinning this wheel, okay? You get to spin it as many times as you want. But if you land on skunk, then you go to 0 and all the money you won previously gets wiped out, okay? Part A, what is the probability that the result will be a number on all of the first 3 spins of the wheel? So the first time you spin it, what's the probability you're going to get a number? 3 out of 4, right? Second time you spin it, 3 out of 4. Third time you spin it, 3 out of 4. So if you want it to happen all 3 times, don't you do 3/4 times 3/4 times 3/4? So does my work on part A make sense?
Yes.
Part B, suppose that you won $800, but you've decided to go ahead and spin again, okay? What is the expected value of his or her total winnings for the fourth spin? So you've got $800, you're going for that fourth spin, and so what are the possibilities? You could land on skunk and go back to 0 1/4 of the time. This is on the fourth spin, you get me? Yeah. I could land on 100 and I'm up to $900 a fourth of the time. I could land on 200, which I would be up at 1,000 a fourth of the time. I could land on 500, and so now I have $1,300 a fourth of the time. Am I making sense? Yeah. You multiply the amount you could win times its probability, and you end up with $800. A contestant who lost at this game alleges that the wheel is not fair. In order to check on the fairness of the wheel, the data in the table below were collected for 100 spins of this wheel. That is observed data. What would we expect the data to be if it was fair? 25, 25, 25, 25. Makes sense? So to work this problem out on the calculator, state plan do conclude, chi-square goodness of fit, I would go, how do I do it again, Barrett? Second plus 4. Okay, stat, edit. My observed list is going to be 33, 21. Okay, just remind me. 20 and 26. My list 2 would be 25s all the way down. Are y'all with me? Stat, test, chi-square goodness of fit. I accidentally did L3 with L4. Is that the end of the world? I hope not. I can fix it right there. What are my degrees of freedom? 3. It is not 99. It is not sample size minus 1. It's categories minus 1. So it's 3. That's for a matrix. Are you seriously trying to stress me out right now? So, everybody good with that?
Yes.
You follow? Good review today? You feel ready? Awesome. 2 or 3 usually.
Don't forget the computer.